Hey gang, Dan here, marginallyclever.com. I want to show you today how to assemble one of these gearboxes. This gearbox is a 105-to-1 reduction. It uses a NEMA 17 stepper motor to get you 20 Newton meters of torque at the output, which is more than enough to run our robot arm and many other applications that your creative mind will come up with. Most of the parts are 3D printed, and we have a kit of just the unprintable parts that you can get off our website. Look for the link in the description. What else can I tell you about this kit? It is, as I said, stepper driven. It uses all metric fasteners. These parts have been designed for injection molding, these parts, the black ones, and it's been made modular so that you can get multiples of these, and then your maintenance and your support work. I needed a really big servo style actuator. I needed it low cost. I needed to be able to 3D print it. So I put all these things together with years of doing it wrong to come up with this design that is pretty not terrible, and I hope you find it useful. If you find that it's good, get a kit. Support us by sharing what you make with your friends, and come tell us about it, because we'd love to show what you have made to the world. You can find us at marginallyclever.com. We have an active Discord channel with members all over the world. I won't give you more spiel. It's a great gearbox. It's a great robot. Come check it out. marginallyclever.com. Also, thank you to all my patrons. You are wonderful. You keep me highly motivated. And here are their names. Okay. Also in the description below, you will find a link to the product page that has the dimension diagrams, the STL files, and where you can get the non-printable components, both if you want to go and shop for them yourself or if you want to get a convenient kit from us. We really appreciate your support, and it's faster than going out and trying to find the exact right fit for every single part of the 63 robot. It can be used for many applications, but we designed it specifically for use in a robot arm. So I'll show you how to put one of these together. In a follow-up video, we will show you how to put a bunch of them together to make that arm, and then you will know how to do it too. Let's go over the parts first, and it'll make it easier to talk about them later. Timing belt, spacers, M3 by 35, M3 by 25, M4 nylock nuts, M3 by 8 socket head screws, M4 by 10 socket head screws, NEMA 17 stepper motor, pulley with set screws already attached, output plate, core, input plate. And then in tools, we have a 3mm Allen key, a 4mm Allen key, a 7mm socket, not required but convenient, and a pair of pliers. Okay, step one, we're going to put the gearbox into the core. Now, for your ease, you can use the socket driver on the end here. This is a 7mm socket driver, but you may find that a pair of pliers is enough. If you leave this on the table, you can then easily grab from one side and look in like that. Gearbox, done. In this step, we're going to put the motor into the gearbox, and along the way we're going to add this timing belt. Make sure that when you tighten, the metal of the face of the motor is touching the plastic of the box. Otherwise, they'll be misaligned and the belt could skip. In the next step, we're going to attach the front and back plates. The back plate is reversible. You can install it this way with the hole at this end, or the other way around. Depending on how you use the gearbox, either way will work. Yeah. At this stage, if you would like to use a drill with a metric head to put your screws in, well, I did it. I recommend it. You can. Most of the time, I would say hand tension, but just to get these started, it saves your wrist. Now, in the back of this gearbox, in the corners, it is difficult to see. In the four corners of the gearbox are slots made for these spacers, but to get them into position is the trick. Double check the wire is good. In the right light, you can see the screw in the corner, and this has to attach in the slot in the corner. Because of the groove, the hex will not turn. Once it has been successfully captured, you see it's holding in place. Now that the four corner posts have been installed, we can proceed with the last section. Here's our assembled gearbox. The remaining 8 M4 by 10 screws can be used for a variety of attachments. One such example is this piece. I caution you, when putting these screws into the gearbox, this is plastic and this is plastic. If you use a drill or you use too much pressure, you will strip this plastic and then the screw will not hold at all and you will lose power in your gearbox. You will lose the ability to turn and move things with as much strength as before. So a caution to you. It's somewhere between 5 and 6 turns. And there you have it. One gearbox fully assembled. Done without interruption in a row. With practice, you can do one of these in under 10 minutes. All right, thank you for watching. I will see you next time. Stay awesome. Dan out.